Okay, so today we're going to talk about two-step equations. And the big idea from two-step equations is equations are a big deal in algebra because generally equations deal with these things called variables, and that x, or that unknown number, is our variable. And the other big idea that kind of comes with this is the equation part, like equal, so it has this equal sign. So an equation really is something that has a variable and something that generally has an equal sign. So we're going to try to solve these two-step equations. You might have seen this before. The basic idea behind solving these equations is we want to get x all by itself, because really what we're trying to find out is what number could I plug in for x to make this side of the equation become equal to 10. And so to do that, if we get x by itself, that would tell us what number we needed to pick. And to get x by itself, you want to undo the operations that are happening to it so that you can get x alone. Normally to do this, if you remember from yesterday, we dealt with something called PEMDAS. And for expressions or things that don't have equal signs, you go the normal way down. You start with the parentheses and you go down. Well, now since we're trying to undo everything in these equations, we're actually going to go in the reverse direction. So because equations essentially mean go in reverse, we're going to do everything in opposite. So normally we would start with this multiplication, but we're actually going to start with the addition and subtraction. And we are going to undo that subtraction. So I'm going to undo that -5, and I'm going to add 5. Now I can't just add 5 to a side without balancing the equation. So I would then have to add 5 to the other side, which will give me 3x. This will cancel out, and this will give me 15. Okay, so now I've got it to here. I still don't have x quite by itself. So now we have to deal with this next operation, which is multiplication. Well, the opposite of multiplication is division. So again, we'll divide by both sides. 3 divided by 3 is 1, so now I have 1x on this side. 15 divided by 3 is 5. So x equals 5. If you want to double check to make sure you got the right answer, just plug it back in to the beginning and see what happens. Well, 5 times 3 is 15. 15 minus 5 is 10. Yep, we did it right. Let's look at some more of these problems. Okay, so for this problem, again, we kind of want to use the reverse PEMDAS. So we want to start, because we have an equation, and I know that because I have a variable and an equal sign. So we're going to go in the reverse direction. So the operation I have to get rid of first is adding 4. So we're going to subtract 4 from both sides, because the opposite of adding 4 is subtracting. 4 minus 4 is 0. 11 minus 4 gives me 7. And now we got to get rid of dividing by 5. So we're going to times by 5 on each side. And that will give me x is equal to 35. Again, if you're not sure, plug it back in. 35 divided by 5, 7. 7 plus 4 is 11. So that works out. Let's try another problem. This two-step is a little bit trickier because of this right here. See how the division sign doesn't just go over the x? It actually goes over both the x and the -7. Because of that, in this case, it's kind of like they wrote it like this. They're like imaginary parentheses around x minus 7. So if you go in the reverse operation again, if we just look back at this, we would want to save our parentheses for the very end, because we're kind of going in this direction again. So we would want to deal with this multiplication and division first. That's going to seem a little complicated. So I'm going to backtrack just a bit. Again, it looks like this. We have what I call fake parentheses because that division bar goes all over it. I like to think of it as the division bar is blocking me from dealing with that 7. So we have to deal with the division first. Well, how do we undo division? Well, we multiply on both sides. Again, if you do 3 divided by 3, that will cancel. 5 times 3 will give us 15, so I'll have x minus 7 equals 15. And then we're just going to add 7 to both sides. That's going to give me 22. Again, if we want to double check, we can. 22 minus 7 is 15. 15 divided by 3 is 5. That all works out. Let's look at one last problem. Now, in the future, we'll learn a little bit of a different way to solve this, but I think the way that makes most sense now is, again, you kind of go the reverse order of operations. And you would say that we would want to do, since we're going this way, we'd want to deal with this multiplication that comes up first. So we have 9 times x plus 4. To undo multiplying by 9, we're going to divide both sides. That's going to give us x plus 2 is equal to 18. Or whoops, not 18. Gives us 2. Because 9 divided by 9 is 1, so it goes away. 18 divided by 9 is 2. Then we're going to deal with this because the parentheses kind of drop after we divide. We're going to subtract 2 from each side, and I'm going to get that x is equal to 0. That's again how we kind of solve all the problems. For equations, you do everything in reverse. So we do the order of operations in reverse. We do the opposite operation to get it by itself. And you can check at the end every single time to make sure you're right. Just like in this last problem, we could do 0 plus 2. It's 2. 2 times 9 is 18. Checks out. So equations are kind of nice in that way. If you need any help, just let me know.